So a better method is where we use something called budget constraints and indifference curves. So a budget constraint, mathematically, if we're looking at two items, B is your budget, and then the price times the quantity of the first item, like the planes, and then the price times the quantity of the boats, those added together have to be less than or equal to your budget. So that's just a budget constraint. So with the price of planes and $10, price of boats 20, and our budget at 80, the example before, this mathematically would be the formula for that, the mathematical equation actually inequality technically for the less than part. And so that's this budget constraint graphically. So given the price of boats, given the price of planes, given our budget constraints, we could at most purchase 8 planes and 0 boats, or 4 boats and 0 planes, or some combination thereof. Some point inside would represent we could do that, but we would still have some leftover money. Now that brings up the idea, well, what's the marginal utility money? That's kind of outside the scope of this thing, but realize that in terms of utility maximization back under the old way, we would also equate the marginal utility of money per dollar spent, which would just be $1. Okay, I hope that made a little sense. Okay, now indifference curves. What we can do is we can think about, okay, if I were to offer you, let's say, 4 planes, and let's say you can have, these are kits and you can get parts of them. I know that's a little hard to see, but what would you be indifferent in terms of a combination of 4 planes and let's say this looks like it's about probably 0.35, 0.4, let's say, boats? Would you feel more satisfied? In other words, would your total utility be higher, less, or the same as if you were purchasing, uh, if you were given the ability to purchase 1.5 boats and 1 plane? And so you can plot those points on out, and that's called indifference curve. In other words, every point on the indifference curve, you are indifferent to that combination. You're just as happy having 2 boats and a little less than zero point 0.9 planes as you are from having, let's say, roughly 3 planes and a half of a boat. So we can plot out various indifference curves. And it's true that the higher the indifference curve, the more total utility you're receiving. Every point on the curve, your total utility is the same with the combination of the two goods in this case. It's also true that these indifference curves will never intersect. That's kind of beyond the scope of what we're talking about here, but that is true. So if we put together in a series of indifference curves and the budget constraint, what we're looking at is achieving the highest total utility, but still being able to purchase that combination. In other words, stay on our budget constraint. And in this example, that would be point E, and I3 in this example would represent the highest total utility indifference curve. Now, we could certainly exhaust our income, our budget, and have this combination at point C, but we're not as happy. We don't receive as much total utility because I3 is higher than I2. So the point of tangency is what we're achieving. We're maximizing our total utility. And so let me leave this slide up just for a little bit so you can kind of see what I'm talking about, and then add another concept, and that's called the marginal rate of substitution of X for Y. We're just looking at, okay, if I'm going to decrease the number of planes that I'm going to buy, what will compensate me in terms of the number of boats that I want to be willing and able to purchase to have the same level of total utility? And so I give you examples here of how you calculate that marginal rate of substitution of X for Y. All right. Now, what you want to look at here is the fact that the slope that you're calculating this in a marginal rate of substitution is nothing more than the ratio of those marginal utilities. But it's important you understand that it's rise over run, so it's the marginal utility of planes divided by the marginal utility of boats. And um, so if we're talking about X for Y, it would be we're talking about X for Y rather than Y for X. So we're talking about boats for planes. So it's the reciprocal of the ratio of the marginal utilities. And so what we're looking at here is back to the idea that we want to maximize our total utility. And mathematically, we can rearrange these marginal utility per dollar spent that we talked about earlier. We can rearrange those and see again that that's the same concept here. And remember, we're wanting to have the tangent point of the highest indifference curve with the budget constraint. Well, that's really what we're talking about here. That's the slope. This is the slope of the budget constraint, and this is the slope of the indifference curve. And so there you go. That's the best way in economics to analyze consumer satisfaction or utility or fancy term consumer preference theory.